All right, everybody, so welcome back. We are going to take a look at the difference between the graphs of a square root function and a cube root function. So first of all, let's just take a look at basics, no translating or transformations. So in this graph, you can see we have a half of a parabola. And again, if we were to complete this, you can see that it is truly, in fact, half of a parabola. It could be the positive side or the negative side of a parabola, but very basics. With a plus sign in the front, you have the top half of a sideways parabola. The cube root function, we have this S shape. Now, just so you know, these graphs would go on forever. I just got them off of Desmos real quick, so I did not add the arrowheads, but they would go on forever. However, this one would not. This square root function has a beginning, and the beginning is very important. It starts your domain and your range. So let's talk about the domain of a square root function. And I think what I'm going to do is I'm going to go through all the square root function, and then I'll go through all the cube root function. So the domain. So what we need to see about the domain is that it is limited. It does not go into the negative region when it's just very basic. Long story short, x is typically greater than or equal to 0 because you can't plug a negative in. So you can have like the square root of -2. That's not possible in our real x and y axis. Now, granted, if there is something else inside of there with x, that would change. So I'll put an asterisk on there and I'll write that it can change, but this is the typical starting value. If it moved to the right, then that would move to the right. If it moved to the left, it would move to the left. Now the range, again, this can change, so I'll just do a quick duplicate of this. But in the very basics, your range is also greater than or equal to 0. Now, if the square root function opened upside down, it would be less than or equal to 0. So hopefully you guys have your auditory on and you are able to see that and hear that. So I have the points up here. Those are just the very basic points. Of course, decimal values do exist within the in-betweens. But let's take a look at what do you think? What x value would I plug in right here for that x to get a 0 in the y? Well, hopefully you're able to say, Miss Angeli, I know that if x is 0, the square root of 0 would equal 0. All right, well, what x value would give you a 1? Well, if you plugged in 1, you would have the square root of 1, which would in fact give you the 1 that's here. What about 2? What would give you a y value of 2? Like if you plug, what x value would give you a y value of 2? Well, that would be a 4. So if you did like the square root of 4, so you're plugging in for x, you're substituting in. And then the last one would be 9 because we know 3 is from the square root of 9. Okay, so what I want you to see about typical square roots with no translating, that's, again, let's just write that because some people don't listen to the auditory. This is with no translations. These are the excellent x's to pick. They are the perfect squares. Okay, so those are your x's you're going to pick, but sometimes those might change if it moves left, right, up, or down. So what basic x values should you pick? You should pick 0, 1, 4, and 9. These are your basic ones to pick. Make sure those are the ones that you end up picking. And you can see, there you go. There are the points that you would get from your XY chart. Now the question might come up now, when do I change my x values? Well, if there is something inside the radicand with x, if it's not just square root of x, you're probably going to want to change your x's so you're not dealing with ugly decimals, okay? So this one has an x minus 1. What that means, go ahead and write, I always have the kids write their typical ones over here on the side. These are like your typical ones that you would pick. However, since this minus 1 means the right? Everything's moving to the right 1 unit. We learned that before, that we're going to move all of these numbers to the right. In other words, we're going to do the opposite of minus 1. We're going to do adding 1 to all of these because we know that it means to the right, and to the right means you go positively on the x-axis. So instead of 0, please pick it 1. Instead of 1, please pick 2. Instead of 4, please pick 5. And instead of 9, please pick 10. So for this particular square root function that has been translated to the right 1 unit, please pick these x values, not these x values anymore. So let's plug that in and see what would happen. We should probably be able to do this in our head, but if we can't, I guess our y equals and our calculator can help us. So let's start by plugging in this 1 right here. So if I plug in 1 for x, I get the square root of 1 minus 1 is 0, times 1/2 is 0, plus 5 is 5. Dangerous, I'm not doing this on the calculator, but that's okay. I can do this live. Watch this. We're gonna, you know what we're really gonna do? We're just gonna cheat. We're gonna duplicate this. we're going to erase this 1, and we're going to put in the 2 that I have over here. So it's going to be 2 minus 1 is 1. Square root of 1 is 1 times a half is a half plus 5 is 5 1/2. All right, let's plug in 5. So again, I'm just going to take this little guy. I'm going to duplicate him. I'm going to erase the 2, and I'm going to put in a 5. I'm putting in this 5 over here. So 5 minus 1 is 4. Square root of 4 is 2. 2 times a half is 1, plus 5 is 6. And now what I'm going to do is I'm going to duplicate that one more time, but this time I am going to plug in 10. So let's see, we're going to take that 5 away and we're going to put in a 10 now. So 10 minus 1 is 9. Square root of 9 is 3. Times a half is 1.5. Plus 5 is 6.5. And you can see down here, I already knew what they were going to be. So here are your points. Here is your 1 comma 5 right here. Here is your 2 comma, what is that, 5.5, and you can see that one's right here. And the rest of that proceeds on. Now you can plug in more points and you can plug in decimal values if you want, but just so you know, this graph will continue. This is absolutely your starting point. If you don't have that point, you will absolutely miss credit. You have to have your starting point, and remember, you just kind of edit it based off the 0, 1, 4, and 1, 4, no, the 0, 1, 4, 9, yes. All right, now what we're going to do is take a look at the inverse of it. So the inverse of a square root says, what is its inverse? Well, if you could take this iPad, let's see, let's go up to the basic one here. Let's take a look at this beautiful graph right here. If you could take this iPad and you could fold it around, let's see if Miss Angela can get this line perfectly. If you could fold that parabola around that blue line right there, I'm hoping you can see that you would get a graph that looks just like this. And sure enough, that's exactly what it is. It is the positive side of a parabola. Notice it's only half of a parabola, so the inverse is half of a parabola. All right, the inverse is x squared, and what I want you to notice about the xy charts, let's do a quick zoom out. This xy chart right here is the inverse of this XY chart and vice versa. I guess I could say this is the inverse XY chart of this. And if you watched previous notes, you know XY charts switch their X's and their Y's. They flip them. So the X's become Y's and the Y's become X's. Okay, I feel like I've done a decent job explaining square root functions, knowing that these are your basic X's to pick, and knowing that sometimes they might move right or left. So I gave you an example of one that moves right. So when you move it right, you add 1. If you were going to move left, please make sure you subtract 1. And then you just kind of like do your basic math plug in and evaluate. Now let's take a look. We did square roots, kind of did that a lot. Let's take a look at cube root functions. So what does the graph look like? Well, the graph has this funny little S shape that goes to the left and the right forever. So you know what we just did there, right? We classified the domain. Since it goes left and right forever, we can say that the domain, the x values, are all real numbers. The range, it also goes up and it goes down forever. So we can say y is all real numbers. Let me give you a hint. 9 times out of 10 is all real numbers, right? So just pick all real numbers on the test unless it's a square root function or unless you absolutely know. So a lot of times we're going to have that all real numbers going on because it's going left and right and up and down. Now let's talk about the x's that you should typically pick. That is your chart here. It says what basic x value should I pick? Well, again, I want you to notice this is absolutely with no translation. So these are the x values if there are no translations. And so if it's not moving left or right. Now, if it's moving up or down, that's fine, but no horizontal translations. So what's easy to take the cube root of? Well, perfect cubes. It is easy to take the cube root of perfect cubes. So what would give you -2? The cube root of -8. So if I wanted to fit this in here nice and small, I could do the cube root of -8, and that would give me a beautiful -2. What would give you -1? Hopefully you know the cube root of -1 is what you should plug in. What would give you a perfect 0? The cube root of 0 is what you would plug in. What would give you a +1? The cube root of +1. And what would give you a +2? The cube root of +8. So let's take a look at these x values. These are the x values that you should be picking as long as there is no horizontal, I'll just put an H there, no horizontal translations. And there is what the graph will look like. Again, you should put arrowheads pointing left and right forever. I just stole that from Desmos, which is why I didn't. Now you might say, okay, Leangeli, here we go. This time I know my math. I can tell you that this is moving left 4 units. Well, that's great that you know it's moving left 4 units. That is something hopefully we've mastered between chapter 4 and chapter 6, where we're at now in chapter 2. So instead of picking, remember the old one, here they are. Instead of picking these old ones, these are our perfect cubes, left, we're going to have to take away 4 from all of these. So do the opposite of what you see inside the radicand. So if the radicand has a +4 here, to adjust for it, we're going to have to do -4 from all of those. So instead of picking -8, please pick -12. Instead of picking -1, please pick -5. Instead of picking 0, please pick -4. Instead of picking 1, please pick -3. And instead of picking 8, please pick 4. Now I know you're dying to know, why is that? Why does that make such a big deal? Well, let's go ahead and plug those in and see that we can actually do this in our head. So there it is. I'm going to go ahead and duplicate that a few times. Oh, just teasing you. There we go. I'm going to put that all the way down. So all I had to do is fill in my x. Notability is such a great tool. And we're going to put the x values in. So on the first one, please put in -12 for x, then put in -5, then put in -4, then put in -3, and then put in 4. And let's go ahead and evaluate what the y's will be. Now, hopefully you can do these in your head. If not, grab that calculator. -12 plus 4 is -8. The cube root is -2. Minus 3 is -5. Here's another one. -5 plus 4 is -1. The cube root is -1. Minus 3 is -4. Here's another one. -4 and 4 is 0. Cube root of 0 is 0. Minus 3 is -3. Here's another one. -3 plus 4 is 1. Cube root is 1. Minus 3 is -2. 4 and 4 is 8. Cube root of 8 is 2. Minus 3 is -1. So you can see we can plug them in our head as long as we're picking these beautiful x values. So, and just to save us some time, I already had this kind of inputted in, and you can see sure enough there are the points -12, -5, -5, -4, and so on and so forth. And you would have to graph those. But again, you get this beautiful shape, and you should notice that from the origin, there's the origin, right? It has gone 1, 2, 3, 4 to the left and 1, 2, 3 down. So the middle point is perfect in line with our horizontal and vertical translations that we used from chapter 2. Now, this last part is, what is the inverse? Well, it's a great question. The inverse of a cube root of x, the inverse is x to the third power. Notice the shape. Now, if you could take the iPad, I'm not sure if this will work, but I'll try it. If you flip it and look at it horizontally, you can see that it is indeed the inverse. All the y's have become x's, and all the x's have become y's. So in other words, the x and the y chart have flipped from the original XY chart before we translated it any way. And that's all there is to it. Even the domain and range has switched. So just a side note, just remember that if you have a domain and range, for example, up here, if you have a domain and range, in the inverse, the range becomes the domain and the domain becomes the range. All right, that was review from last section. Whew, that was like the quick version. Now let's try it yourself. Find at least 4 points of the square root function. Make sure to indicate the first and most important point. So what I'm going to do is I'm going to look and I'm going to say this is a square root function. So Miss Langeli told me to reference my perfect squares. Those are my perfect squares, and adjust them if needed. And in fact, I do need to adjust these. So hopefully you see this -2, or excuse me, you see that +2 on the inside. That means, hey, you better adjust those by moving them to the left 2 units. So I'm going to have to take away 2 to adjust for that. That's not an exponent. I know it looked like it. It's not an exponent. I was just trying to write -2. So instead of plugging in 0, I need to plug in -2. Instead of plugging in 1, I need to plug in -1. Instead of plugging in 4, 2, and instead 9, 7. And then I should be able to complete these in my head. If not, that's why we have a calculator. Let me do a quick duplicate of all of those a few times. Whoopsie. I didn't mean to grab all of that. There we go. There we go. And there we go. Okay. So what I'm going to do is I'm going to put in those x values. What do I have? I have an x value of -2, -1, 2, and 7. So the first one doing that will be 0 minus 4 is -4. You can absolutely use a calculator. This will be the square root of 1 times 3 is 3 minus, it's -1. That'll be 4. Square root of 4 is 2. 2 times 3 is 6. 6 minus 4 is 2. And let's see, that'd be 9. Square root is 3 times 3 is 9. 9 minus 4 is 5. And I think those are all good. I'm just going to do a quick double check in my head. 0, 1, 3, -1, 4, 2, 6, 9, 3, 9, 5. Okay, I think I got them all. I'm going to graph those points. So -2, -4, 1, 2. Whoopsie, didn't give enough of a graph, but that's okay. -1, -1, 2, 2. And what I want you to see is this has been vertically stretched by a factor of 3. It has moved to the left. The origin of the original spot is no longer on the origin. And it has moved down 4. And let's see, where are we at? Over 7, up 5. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5. The graph isn't quite big enough. Let me just double check. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5. And give it this parabolic shape, half of a parabola. Make sure that you don't go over here at all. It should not include anything past the original spot. So we have our original spot, and we have this parabolic vertical stretch there. So let's talk about our translations. Oh, by the way, the domain, great point. Domain, domain, domain has to do with this first x value. So usually it's x is greater than or equal to 0, but because it got moved to the left, it's actually x is greater than or equal to -2. Please make sure you draw the arrowhead, pause the video if I'm going too fast, and kind of look at it. And the range is usually y is greater than or equal to 0. However, this did get moved down 4 units. So since it got moved down 4 units, the range is everything greater than or equal to -4. It's not been reflected, so the greater than signs stay. All right, that's the bell, so the cube root function is going to have to wait for the next video.